Hi friends, the more things you don't know, the more opportunities you have to learn. A p orbital of an atom. If the bond axis is the z-axis, then which orbitals can overlap with which orbitals to form which bonds? This problem is quite simple. We won't have much difficulty. As a refresher, we will explore the concept of sigma bonds and pi bonds. The image on the monitor screen is a p orbital of two different atoms. We only show one p orbital just to simplify the animation. One p orbital has two lobes separated by a node. These orbitals are parallel to the horizontal axis. When two atoms form a chemical bond, they will move towards each other. The lobes in the middle of the orbitals will overlap. They form a new lobe. Now, this kind of bond between orbitals is known as a sigma bond. So, what about the pi bond? Now we will look at the p orbitals of two different atoms that are parallel to the vertical axis. When the two atoms form a chemical bond, the two upper and two lower lobes will overlap each other. The two upper lobes will form a new lobe, and the same goes for the two lower lobes. The two new lobes are separated from each other. This kind of bond is known as a pi bond. I think this concept is very clear. Back to our problem. This center of coordinates is the nucleus of the atom. All these orbitals are centered at the same center of coordinates, meaning they all come from one atom. Since we are asked to analyze the orbital that overlaps the blue orbital, we can ignore the other orbitals. Since the blue orbital is parallel to the x-axis, we can call this orbital px. This atom will form a chemical bond with another atom. Since the bond axis is the z-axis, the other atom will be directly above this atom. We don't know which atom it is, but it certainly contains a variety of orbitals. There are 5 possible answers. We will examine each one, starting with option A. The dxz orbital has 4 lobes, each of which lies between the x and z axes. When the atoms form a chemical bond, the 2 lobes of the dz orbital touch the lobes of the px orbital. Since the 2 lobes are not aligned, they tend to form a pi bond. Why does this seem like the answer? What about the other answer choices? There may be several correct answers. In option B, we have ADZ to orbital. The shape of this orbital is to lobes parallel to the z-axis. Right at the node, there is a torus parallel to the xy plane. When atoms form a chemical bond, the lobe on the upper atom touches the node on the lower atom. The 2 orbitals will not form any bond because the electron density at the node is almost 0. There are no electrons there. Electrons are only collected in the lobes, not the nodes. Option B is incorrect. For option C, atoms with pz orbitals. The pz orbital shape is to lobes parallel to the z-axis. Similar to option B, when two atoms chemically bond, it turns out that the upper atomic lobe meets the lower atomic node. This process does not produce interactions between orbitals. Statement E is similar to Statement C. Both answer choices are incorrect. Now option D, atoms with py orbitals. The py orbital shape is to lobes parallel to the y-axis. When two atoms chemically bond, it turns out that the upper atomic node meets the lower atomic node. Because there are no electrons at the node, no chemical bonds are formed. Statement D is also wrong. It is true that only option A is correct, so the answer is A. Happy learning, everyone!